Sahara is a reservoir visualization, analysis, and management software. It was conceived to manage the high volume of information required to understand the physical behavior that drives a reservoir in an integrated way. Its calculation tools allow the user to quickly obtain a variety of results that are helpful for reservoir analysis and management. A wide range of 2D and 3D graphics provide a great variety of visualization options. You will notice as you progress through our demo that a special feature of Sahara's windows is that they communicate with each other, thus permitting information to be globally accessed. So, let's now begin our demonstration with this example that shows a geological structure defined by 3 formations, each of them composed of several layers. The button bar at the top shows different field zones. This characteristic of Sahara gives the user easy access to information at the layer level. The map window shows data corresponding to the active layer, in this case A2. The net thickness map is currently on screen. The blue lines represent water-oil contacts and the red lines represent faults. The set of symbols displayed here represent the well's location and its producer or injector and open or closed status in the active layer. The well status information is dynamic. At the top of the map window, there is a slider that allows the user to analyze the evolution of the well status through time. The curves configured in the production window are displayed each time you select a well in the map. In this example, the green curve represents oil and the blue one liquid. You will notice that some layer names in the button bar appear in green. This is to highlight the layers at which the current well is open on the selected date. If the user activates the lower chart and clicks on an injector well, its total water injection curve will appear in blue, and its water injection at the selected layer in magenta. The possibility of dynamically consulting different wells in different charts allows the user to quickly see the interaction between them. By moving the slider in the chart from side to side, the user can easily determine the interaction between wells in secondary recovery. If the user selects a producer and injector well, he will see the simultaneously open layers of both wells in red. The user can open the cross-section window and select 2 wells. In this window, the user can see electrical logs, layers correlations, and workovers. The user can view a well's casings and production strings by opening this window and clicking on the well on the map. The user can also view logs, layers, open zones, flow test results, and injection equipment, such as packers, mandrels, etc. By clicking on a flow test, its results are displayed as a pie chart. Producer well information is easily accessed by selecting it in the map window. The map window shows the maps available in the project which have already been imported or created within Sahara itself. The user can add to the chosen map its contours with its values and simultaneously overlay other map contours. In this example, the user can see the structural map with the contours of the net thickness one. The user can add more data, such as the cumulative oil per well in bubble format. As all this information is dynamic, the user just needs to move the date slider on the map to see the changes through time. The information can also be seen at layer level. By changing the layer, the user can see the cumulative production in each one. If the user selects all the layers, total well production will be displayed. If instead a pie format is selected, the production per layer and its values or percentages will be displayed. Sahara is capable of working with many production scenarios. The user can not only load in the production history, but can also import results from other applications, such as simulators, or generate forecasts within Sahara itself. Let's create a new scenario to store forecast data. The decline analysis module presents several work templates. In the flow versus time template, let's select the phase as well as the data and result scenarios. The module is very interactive and allows the user to perform a quick history match. To do so, you only have to move the date lines which delimit the data zone. The forecast options provide the usual features for this kind of work, as well as others, which you will find only in Sahara. For example, a very useful template is the one which allows the user to simultaneously work liquid versus time and WOR versus NP. The user can assign a constant value to the fluid. As the representative zone of the water-oil ratio trend is adjusted, the oil flow is automatically calculated and appears in the top chart. Once the adjustment has been finished, the user can record the forecast in the result scenario and see it in the production window. We can repeat the same procedure for any number of wells and then obtain the total production of the group. Sahara has several petrophysical-oriented tools. The log calculations window allows the user to obtain new curves by means of correlations. For instance, the user can select the porosity option and then configure the window to calculate a new total porosity curve using the density log. If the user so desires, he can set the matrix and fluid density values. Let's select all the wells which have a density curve. At the same time, let's select all the wells that don't have a total porosity curve. The calculation can be performed for a set of selected layers, for a defined depth range, or for the whole depth range. The newly calculated curves can be displayed in the logs window. Let's add a 5-division linear track to the active template. Now, let's add the total porosity curve to this new track and set a 0 to 0.5 scale. We can now choose a cutoff value of 0.15 and the zones between the selected value and the porosity curve are then painted in color. This information can be displayed as an electrophases map. The summations window allows the user to calculate layer values from a set of curves. We have created two variables to hold net thickness and porosity values for a 15% cutoff. Let's select the NT15 variable. In this case, the calculated net thickness at 15%, the summation operation, and a porosity higher than 0.15. Now, let's select the porosity variable as an arithmetic average, the total porosity alias curve, and the same condition. Let's also select all the wells with porosity curves. Now, let's select all the layers and calculate. Using a bubble map, we can compare the original net thickness values with the values obtained for a 15% cutoff. The bars format is particularly useful for this kind of comparisons. Having opened the Cross-Sections window, let's now select a path on the map by clicking on a set of wells. This window has numerous tools to define layer tops and bases. For instance, we can drag logs between wells to find correlations. The user can also drag the picks defined in a well and assign them to another one. If so desired, we can modify these depths. The mapping window allows the user to generate grids for any variable by means of different interpolation algorithms. The user can select dynamic variables such as the cumulative oil by layer. Let's select the net thickness map as the calculation domain. We now select the Shepherd algorithm and calculate. The user can set the active date by dragging the date slider. The user can select a static variable, such as the calculated thickness at a 15% porosity cutoff. The user can also select all the layers and apply the calculation to all of them. The volumetrics tool allows the user to perform volume calculations on any map in the project. Let's draw a polygon to define the calculation area. In this case, the net thickness map is selected, and once calculated, the user can see the rock volume of the selected layer in the area delimited by the polygon. If we select all the layers, we can obtain the rock volume of the whole field in the same area. The values are displayed using the units that have been set in the project. If so desired, these units can be modified. For example, area in acres, thickness in feet, and volume in acre-feet. With a simple recalculation, the user can display the values in the newly selected units. The 3D window has many visualization options. The vertical scale can be adjusted. The structural surfaces, or the volume of selected sands, can be displayed. If so desired, Sahara can paint these with any map attribute, such as net thickness. The user can add the zones for the selected well and its logs. The neighboring wells and correlations can also be displayed. Casing and production equipment can be displayed as well. If a layer variable has been selected in the map window, it can be displayed as bubbles in this window. Sahara includes an injection pattern simulator for secondary recovery projects. The injection pattern system, which is defined at layer level and can be automatically generated, is dynamic, reflecting all well perforations and conversions. The history match and production forecast can be obtained employing various calculation methods. These will be based on the injection of each well at each layer, the geometry of the patterns, a given areal distribution, and the petrophysical properties of the layers. The available methods are segregated flow, Buckley and Leverett, and Craig, Geffen, and Morse, as well as two empirical methods. As this is an analytical simulator, the runs take only a few seconds, and very detailed history matches and forecasts can be quickly obtained. Comparing different runs is very easy, as the results of each run can be saved in different scenarios. In this map, the user can see the injection and production flow rates of each well, as well as the map of the recovery factors for each flow element. Let's select a template to analyze the injection pattern balance of the injector wells in the production window. In the top chart, the user can see the oil production generated by each injector well. Solid lines represent the flow at well level, and dotted lines at layer level. Injection flow rates and associated fluid production are displayed in the bottom chart. Their corresponding cumulatives are displayed on the right axis. The Reports window allows the user to review layer-related information, such as contact volumes, injected pore volumes, cumulative flow rates, current saturations, and residual oil. As you have seen, the main difference between Sahara and other E&P applications is its ability to handle reservoir information in a fully integrated and friendly way, and at the same time, It allows for interaction between different user profiles because Sahara offers analysis tools for engineers, geologists, and technicians.